Okay, so this is another example on linear law. Just that now it's slightly different. There's no diagram, but it's a whole bunch of information given, and they expect you to find the values of the value of A and of B, the two constants here. Okay, so what we're going to use here, actually, if you think about it in the big picture, is to use the basic idea of comparison. Okay, so we're going to form certain expressions, and then we're going to do a comparison. So if you take a look at this, y equals to 1 over ax minus b, clearly is not a linear expression. So what I'm going to do is I'm going to rearrange it such that I get a linear expression y equals mx plus c. So let's do that. Multiply this by on both sides. So it's like cross multiplying. I'm going to get axy minus by equals to 1. Okay, do some rearrangement. Bringing this over here, and I'm going to get axy minus 1. Okay, almost there. Recall that I want my coefficient here to be a value of 1. So I'm going to get divide by b throughout. And I'm going to get a over b times xy minus 1 over b. Okay, so this is like my y equals to mx plus c form. Alright, so now I'm going to look at the information given further. They said, oh, if I were to change this into a straight line similar to this, I would get a gradient of 3 and a y-intercept of this. So basically what we're staring at here is that, oh, I've already sort of changed the nonlinear expression to a linear looking form. And the gradient from the information there takes on a value of 3. So it must be by comparison that a over b is 3. Not only that, the y-intercept is a value of negative half. So it must be that negative 1 over b is the same as negative half. So by comparison, it must be that b takes on a value of 2. So with that, if I put it back into this first expression, a over the value of b2 is equals to 3. And hence a takes on a value of 6. And there you have it. The values of a and b.